All right, recording. Hello, everyone listening on YouTube. This is the Computer Over Data Working Group. This is our 14th session together. And today we're joined by Michael from Humanity, and super interested to learn more about his product and what they're doing, particularly to help us think about how can we improve the quality of our lifespan, as well as sort of how data fits into all that. And this decentralized data, managing of data is something that we're all spending a lot of time on as well. So one quick promo, the COD Summit is coming up. It has a date now, May 9th through 10th, and I'll just share my screen briefly. If anyone would like to propose a talk, please send that our way. You can post it in the Back of the Out channel on Filecoin slide or in the Computer Data Working Group channel. Please go ahead and start thinking about that. And as soon as we have registration details, we'll send that out to everyone who attended last year as well. So that's all I have. Michael, if you're ready, I will stop sharing and let you take it from there.
Perfect. Thanks, Wes. Yeah, good to be here. Let me grab my slides here. There we go. Cool. So maybe a little bit differently than some of, or maybe your more regular talks, this will be a little less technical. This will be more on the operational side of like, how do we, what's the impact in product side, and what are the pragmatic technical decisions that kind of at least went through our heads when we're thinking about how to set up the system that I'm going to talk to you about. So first, who am I? So I'm Michael Geer. I'm a co-founder of Humanity. This presentation throughout, you'll kind of see, will be different. We're talking about two companies because the proof of concept that we're looking to do is between our two companies. And so the other company I'll be talking about is Wild.ai. And my friend Helene runs that. And so the whole idea of this whole thing, just so you have a framework, before I dive into detail, is we're basically two consumer health companies, and we want to see, can we keep our user data completely private, but at the same time train our models across both our data sets, which has a lot of obvious improvements, but the main one being that our models that we then provide to our users to make them healthier will be more accurate and better. So Helene's platform is another consumer health application, but hers is very focused on female sports performance. And so it comes from that idea that, okay, there's a lot of differences between males and females, and we need something that actually, especially when you're talking about, peak sports performance, there's a big difference. And that's what she's focused on. And Humanity has a bit of a broader focus, which is we're, some would think of us as like a longevity tech company, but we're very much focused on increasing your health span. And so we're a traffic navigation app, but for health, meaning we're taking in all the data and watching what everybody's doing. And we're then guiding you to tell you, hey, it looks like if you do this, this, and this, you particularly, not just the general public, you'll actually slow down your aging, which means that you're going to have more healthy years. And so really to bring the focus for this talk onto the data. And so I like this title because it at first sounds like hyperbole, but then when you think about it for 2 more seconds, it's like, no, yeah, actually it's doing that. And so we all, I'll be preaching to the choir and probably actually the mainstream now with all the AI kind of examples, but we all know that AI, given the right amount of data and the right data, can do amazing things. And so I think it's about time we all kind of get over that. First question was, if we have more health data and the AI works on it, will it actually be able to help us be healthier? I think we should just say, yes, it will. And so let's get access to more of that health data. And so really on a day-by-day basis, our lack of the right health data to train models that then are used by not just consumer health companies, but by hospitals and others is actually leading to more death, leading to more unhealthy people. The thing that made me actually early on, even before we launched Humanity. So my background, I launched one of the biggest dating sites in the world called Badoo. my co-founder launched one of the first social networks, had 1 million users before Facebook, and got quite big. And so our whole specialty is getting things out to hundreds of millions of users. So when we delved into the science side of things, it was a lot of me just spending time in labs and just talking to people and not really having a specific agenda other than I wanted to find out, how can we detect cancer earlier? Like I started with certain questions, but it got wide pretty quick. And what I realized when talking with all these people, and luckily enough, some of the top names that you would see in any particular field are actually sometimes quite generous with their time. And I'd be sitting with this person who, I knew their name because it was the name on the model kind of thing. And when they actually told me their story, it was like, oh, wow, you spent like 90% of your time just collecting the data and only 10% of the time doing all the analysis that you're known for. And that seems, and when that became a repetitive story, when talking with each of these people, it was like, oh, wow, that's highly inefficient, but also I would say the bigger problem here is not just that, say like Steve Horvath or in the longevity space or George Church needs to spend a ton of time collecting data. It's that most of the time that data can only be collected by the likes of Steve Horvath or Cynthia Kenyon or George Church. A lot of times the access to the data will just never be for the other 8 billion of us. And so that's a big, the access and the time that it takes even for the top people to get the data is huge. And then harkening back to very simple statements but very true is I think people that spend time in the healthcare space know that it's quite a meme, and because it's actually very true, is that a lot of clinical trials for years and years and years were not even having like female data in them. For various reasons, none of them that great, but that's what it was. And so you can expect when you build a model or come to an understanding based on people that are not the people that you're going to apply that model to, you could very clearly understand why that would cause problems. Basically, you won't get the effect that you want because you trained on a data set that's not a good reference. And so in real terms, we need to get access to all the data that's actually relevant to the cohorts that we're going to try to help. So I'm going to walk you through what we're building. I think this whole talk is about, because I think one of the greatest things about this group and the talks that you guys have is it's not about me marketing specifically, hey, we're doing cool stuff. It's more probably people watching this video might actually be able to help us, build this cool stuff. So I'll try to give you little pieces of it that might not seem necessary for the storytelling, but might be necessary to see how you might, be able to help out. And so what we start with is actually there's a ton of health data out there. And so I know there's a lot of initiatives like how do we get people to donate data? How do we, I personally think they're unnecessary because there's a ton of data out there, even in just the consumer health space, just a ton of data. The question is more, and probably the quickest path forward, at least that's what we've come to, is how do we unleash that data? How do we open up that data to model training while at the same time keeping it completely private? And in the past, that was a trade-off, and I think that trade-off doesn't exist anymore. I think we can do both. And so what you're seeing on the map here, so what we have is Humanity, which is a consumer app, as I said. We have right now like 155,000 users. So we're getting billions of data points, biomarkers, movement patterns, actions, all that sort of stuff. So all that real data. Wild AI, slightly less users, but similar kind of data pouring in. And then I just have the kind of like representative, like there's a clinical trial or there's a research study, as well, just to show that this isn't just for consumer health companies. This is, name your group, your hospital group, or whichever group might be collecting a lot of health data, allowing them to come into the system will be helpful for every single player. And so we want to keep that private, right? So in the past, you kind of have anonymization and then these kind of bespoke, bilateral deals where, okay, we're going to anonymize this data, then we're going to, share it, but only with this group, or we're going to share it, but only in this, this secure data environment. But the big problem with that is it severely limits access to that data, meaning the person, maybe even one of you watching that might not have like all the connections in the world, the person that has a brilliant idea and some machine learning skills, if they're not able to access the data, that brilliant idea will never turn into a model that then saves lives. And so having any kind of restriction on who can train their model on the data from step one has a big impact change. Much like if only a few of us had access to the internet. I had the pleasure of getting to hang out with Tim Berners-Lee when I was running a consumer VPN in a different lifetime. And if he hadn't created the World Wide Web, he didn't create the internet, he created the World Wide Web, the impact wouldn't have been, even 1/100th of what it ended up being, probably 1,000th. So we're keeping the data private. So what are we doing? We're creating synthetic data in its early days, but we're creating synthetic data from our real user data. And the main reason for that is because we want to really open up the access on the far end of the system. So once all this data is opened up and there's federated learning across it, we don't want a big limitation, on the access to be able to train a model. And so taking that decision to do synthetic data as opposed to federated learning using differential privacy and possibly homographic encryption, people watching this probably know 3 other, ways that you can add privacy into that. Just didn't seem like it was going to be good enough to not have any or almost no restrictions on the far side of the system where people are training stuff. And so we have our real user data, we create synthetic data. And then the last piece of this POC is you have a federated model. Sorry, that this is the one slide in this that my designer didn't do. So I'm sure you can recognize that very clearly. You have different people, and it doesn't have to be just the people that have inputted their data. You have different people training whatever model. So like in Humanity's case, we'll be training a model to figure out the impacts of different actions you can take throughout the day on the particular person that you are, on the endpoint, which is increasing your health span, so decreasing your chance of future disease. And so that's our model. But then Wild Data AI might have different models, right? They might be like, okay, how do we basically figure out the peak times and the peak actions for a female that's in this particular part of her cycle to, what is your training plan today? And so everybody will have different models, and then a research study, the sky's the limit, right? Any question that we have about preventative health for this particular type of data, you'll be able to answer it because you'll get access, because we can get pretty, wide open access. You'll be able to actually train your models. You'll be able to come up with your final thing. And hearkening back to, Steve Horvath in the longevity space, spending 90% of his time just collecting the data. All these research studies, not just the ones that are started now, will be cheaper because they don't have to collect the data necessarily, but there will be more because the price to learning ratio drastically changes when most of your cost will be the collection of the data. When you get rid of that, imagine the questions that we can answer for a lot cheaper. And so that's a system, and I hopefully in the group, and you'll notice that I don't talk necessarily about Web3, but obviously everybody with a particular skill set can quite easily probably imagine how Web3 can play into this, where you have either, the group name, you either have this kind of distributed, compute, you have distributed storage. All these kind of things are open game for making this a viable and a robust system. And so this is just like again, poor visualization, but kind of like all of us have probably gone down through, some Chat GPT or, Bing AI rabbit holes the last few weeks. I think the thing that really struck me finally with all that is that it understands me. No matter how I try not to be rude to it anymore. I think I was a little rude the first couple of times, but it gives me an answer to my my prompt. It's not quite right. No matter what inane way I come up with, kind of trying to direct it to get closer to what I had in mind, it almost always understands me, which is just an insanely different experience than MySQL or anything else you might have used in the past, or keyword kind of systems like search. And so you can imagine if you have all this data within Access to tune a large language model system, you can imagine that not just with anybody with a certain skill set can then interact with that system and come up with answers or different research or better models for people. Really anybody now can interact with it because large language models kind of like change the game in that interaction place. This was one I gave this part of this talk at Decentralized Science in London, which was a great conference. But I think ChatGPT, this was the first prompt I gave it, really pointed out that the most interesting stuff was it increases the diversity of perspectives. That's also on the data side, so the reference data, but also obviously the research that's done, and then more accessible to researchers and communities that have traditionally been underrepresented in science. And you can name a few that are definitely underrepresented, but I think you can really widen that out to, like, if there's 1 million people doing science research, there's 8 billion people not really having that much access to it. And I think a system like this and large language models built on top really changes the game on that. To give you a bit more specific of what we're doing with Humanity, because I think concrete examples usually can help, is so we're basically saying, so if you look at the chart on the right, these are very big blocky cohorts, but just for representation. So you have female of a higher BMI, female of a lower BMI, male of a higher BMI, male of a lower BMI, and then the different actions they can take. And this was just a sampling that we took out. And I think the one thing you can take away from this chart is that the bars are different. What we've seen in our real data is that the impact of different actions for different types of people is different. That probably was always an obvious statement, but now we see it very clearly in our data. And what that means in reality is our app should not be guiding different people to do the exact same thing. Personalized guidance in health makes an impact, and that impact is judged against what we're seeing in our models, that endpoint of predicted future health. And so get access to more data, you get better, guidance. Just again, for more of like describing our concrete system. So I'll walk you through, kind of a user flow here, right? So we, one of our friends and investors is Jane Metcalf. She was the co-founder of Wired Magazine. And so I use her as an example sometimes. So Jane, she joins, so this is a user flow, and then I'll show you what's happening in the back end. Jane, she joins Humanity. We pull in all her digital biomarkers. That's things like movement pattern, second by second, heart rate pattern if she has wearables, which Jane definitely does, second by second. And that's getting you back this biological age. For the user, really their next step is they're just getting guidance, and they have points assigned to those actions. So 10 minutes of moderate intensity activity will get you six points. But what happens in our system is, possibly for me, as opposed to Jane, maybe I'll get 10 points. Maybe Jane's doesn't need as much moderate activity. Maybe she needs more sleep than I do. And so that's how the user identifies with that, is they basically get different amounts of points depending on who they are. And every day she's just trying to get her score up to 100, just like all the other kind of gamification you've seen in the past and what we've done in our companies with the dating site and social network. And then really the end goal is to slow down your aging, is basically to have a lower biological age, which basically means that you have the health risk factors of a person younger than your chronological age if you have it lower. And that's the whole goal of the thing. So after a week and a half, maybe 2 weeks, you'll start to see your rate of aging change if you're following the guidance and keeping your score up. So importantly, though, what's happening in the back end? So like I said, she joins. We take all of Jane's kind of digital biomarkers from Apple Health Kit in this case. What we're doing is we've trained a model on external longitudinal data sets. And so again, access to data. So these longitudinal data sets are fantastic. That means they've been watching the same people, so the same participants for decades. And so UK Biobank's been watching for about 2 decades now. They have about 500,000 people they've been watching for 2 decades. Different biobanks, Estonian Biobank in the US, you have Framingham, you have Jackson Heart Study, you have a bunch of them around the world. Dunedin, you'll hear a lot about. Dunedin has a good biobank out in New Zealand. And so basically you train the models, the predictive models on that longitudinal data, which basically says, this is what we've measured on people in the past, these participants, and then this is what actually happened to them health-wise for the next 10, 20, in some cases 30, 40 years, depending on the biobank. And then what we do is we pull in Jane's, those similar markers, the same ones maybe. So the UK Biobank, we're lucky 100,000 people 18 years ago had accelerometers and heart rate monitors stuck onto them for about 8 weeks, I believe. And so that gives you a pattern. You have future health. So we've taken her digital biomarkers and we basically compare it to that pattern. We give a biological age. And so that's great. Now we have an endpoint. That endpoint is we're trying to push off disease for Jane. Then the other side is very much like Waze, the traffic navigation system, is you're looking at these, actions that you can take during the day, and we're monitoring what actions she's taking. And we're basically saying, okay, this group of actions and all the attributes that make Jane Jane goes into that action navigation model. We then tag all those actions with, did it improve that endpoint? Did her biological age go up or down? And, rinse and repeat every single day. And you start to actually get different coefficients, different weightings for different actions for the type of person that Jane is. Of course, as you get 100 Janes, well, there's only one Jane, but 100 people like Jane, 1,000 people like Jane, her guidance will become more and more accurate. And on the wild.ai side, the mission, let's go back to the missions, is, you want to provide them with actually personalized guidance to help them in the different stages of their training. And in ours, very clear mission, we want to add 1 billion years of healthy years to people before the end of the decade. And we've given back about 50,000 now, according to the models. So basically added 50,000 healthy years to people's lives. And none of this is possible without data. The great thing is we have more and more sensors out there. We have more and more data being collected. How do we open up access to that data while keeping it private? And hopefully our proof of concept, which we'd love to have, people help with, is one big kind of step and one big beacon that we can show that it's possible. So thank you.
Fantastic. Thank you so much, Michael. What an incredible vision of bringing the data together. And you've hit on a lot of topics that we've talked about in the community more recently. I mean, Pedals.ml folks were on, and they were building large language models in a distributed way. So this is really good fodder. And I appreciate that the aspect that not only are we talking about like underlying tools in the community, but also having real use cases that makes unique value from those tools. Could you say anything else about, from the analytics perspective, just as sort of as a layman doing traditional analytics, I might say, this person ID 1234 exists in a couple different databases. I'm going to try to find people that have this scenario and these sets of scenarios and outcomes. And then when you're thinking about behaviors across different synthetic data sets, do you still need that correlation back to an individual for analytics purposes, or could you kind of achieve the outcomes without that kind of correlation back to a single person, even an anonymized person?
Yeah, it's a great question. I've spent most of my time, and the folks I'm working with have spent most of our time, and I always forget which is vertical and which is horizontal. Let's say we've spent most of our time on the vertical federated learning. If I'm getting the terms mixed up, let me know. But basically, that means that we don't need the same person we don't need to know that the same person is in 2 of the nodes. in the federated learning system. So we're not trying to combine different types of data on the same person across the federated learning. We're basically trying to increase the amount of people that we're able to train across. So, you know, doesn't necessarily need to have overlap. It doesn't hurt too much, even if there is. But basically, we don't need to know that it's the same person across each. There's definitely, maybe to go a little bit deeper into that, but then this is getting more into conjecture, is there's definitely a lot of learnings that can be had that then can be put back together. So basically, synthetic data is you're doing deep learning on a data set. What that deep learning is just much better at today than it was 10 years ago is it can pull out all the relationships between, you know, multiple variables, right? Relationships that we might not have, you know, done with our analysis in the past. Those relationships can be, if you have the same type of data, so not the same person, but the same type of data, you can almost sometimes use that as a link. So you're basically mapping between different learning groups of, you know, how different variables work together. Anytime I get an explanation from a physicist, I understand it. So you might catch a little bit like bodies in motion in a confined space is like how I think about everything. And so I think you do get those learnings can be applicable even if you weren't able to identify that the same person had them, as long as you have enough people that have different forms of overlap between the different types of variable. Maybe that wouldn't make sense, but that's at least how my mind works. So.
No, it's an interesting point. Maybe clustering or sort of automatic cohort peer group identifications through like the deep learning training. Maybe that could be a part of the ideal algorithm.
Yeah, I think there's this system is definitely best suited for coming up with learnings that then can be applied as long as you know which strata to put people into. I think if it's trying to be like that first step of almost like combining data that's been separated on the same person, I think federated learning just on its own is fine doing that. I think the learning step and the modeling step can be, even if that's the first step, the next step could be the system again, once you've combined it with the federated learning. So.
Very good. All right. And Alexander, I know you joined us as well. I want to give you a chance if you have any questions, to give you some space as well.
Yeah, so that was great. I'm still thinking, see if I have any questions or any thoughts to share, but otherwise it was a great presentation, and it's a great subject. I really like the health area, so it's nice.
What do you work on today?
I'm mainly working with open ecosystems coordination and tooling, so helping companies and projects grow their open source communities and projects and whatnot. So, but I've researched a lot in the neuroscience field. So, so I guess if you could elaborate a bit on the relationship, how do you think? So, what do you think about having the relationships be kind of interoperable, so you can, like you said, you could exchange or use the same relationships based on if they have the same relationships, and how would you deal with the nodes, and how would you back that with the relationships so they can be shared across different data sets using, so you would change nodes but you keep the same relationships. So maybe optimize the models and whatnot. So how do you think about that?
Are you saying, just let me try to understand your question. It sounds like a good one. Are you saying that, okay, you train a model against a few of these nodes data, it would then be optimal to then take that model and train it against or test it against a few of the other nodes? Is that the direction you're going? Or? Yeah. I think a lot, I don't focus on it at this high level, but I think there's a lot of functionality in federated systems where, such as, okay, these are going to be by my these are my training nodes, the test nodes, or just simply knowing the metadata there so that you can make all those different decisions, like include these nodes when you train the model. I think that's super important, because people do care where the data comes from. They do want to be able to, in many cases, do that assessment themselves. I don't know how. There's probably others, people that are working on, kind of rating systems for nodes and things like that, and there probably are things that should be there. But I think just having the metadata and being able to take nodes in and out of your model training, people will be able to do a lot with that to figure out, well, if this data just doesn't seem to seems to be really pushing our model in some weird direction, where did it come from? At least give me the the name of the company or the source. And I think that should be, I don't think there needs to be like a full anonymization of who. Actually, there probably shouldn't be a full anonymization of the nodes that are in this. There should just be the privacy for the user data. So, but I think, there's a lot of, as you mentioned, I think there's a lot of great reasons why you would want to know and be able to take nodes in and out of a training. I think the other thing, actually, that brings up even another point on the more detailed side, but I think important side, is another reason for say, because the question sometimes comes up like, okay, why don't you create the synthetic data and just all put it, centralize it? There's a couple big reasons not to do that. One is a lot of this data is, well, almost all the data that I can think of that would be useful in health, a lot of it is going to be dynamic, as in you're going to be getting new data types and just new people into the system. I mean, case in point, the ones here are, we get thousands of users every day kind of thing. So you would want to be able to have some, I don't think real time really comes into play for almost a lot, for most of the health stuff, but let's say a monthly kind of update of the synthetic data node from the real data, which has changed, or at least expanded. And the other one is, I think there's a lot of unseen things here where there's different methods to create the synthetic data. So there's different GAN methods, there's different, especially time series data, like that's an evolving space. And so I could definitely see, if we want to make this as applicable as possible to as many people as possible, I could definitely see a future where someone would be trying to train their data across a couple of these nodes or 10 of these nodes and be like, you know what, the synthetic data is just not, or this particular data is just not exactly the way that we need it. So their ability to actually just ping those nodes and say, hey, would you mind running this GAN on your data to update your synthetic data or create a second synthetic data set? I think that ability will actually be quite functional and keeps us from the need to predict every single way that someone's going to want to train on the data and what, because it's very hard to test for whether that would work. We can definitely test if our models that we're building will work the same on our real data and our synthetic data, and we can do that with a couple close partners. But when you open it up, you're not going to necessarily know if people training on the synthetic data is not losing any information. So.
Awesome. Yeah.
Very good. Michael, thank you so much for the content. The last question I have for you is, how can folks get involved? How can they reach out to you if they have ideas for solutions? How can they get involved and using the app, contributing to the ecosystem community, anything they can do to get involved?
Yeah, great question. So I think, yeah, anybody can, with an iPhone right now, can download the app and start using it. And that in and of itself, adds to the data set. So, and we like to think it's going to make you healthier. We will have Android, at least a beta version, in a couple months. The main components here is, and they can actually be kind of done separately. It doesn't need to all live within a particular system, is the federated learning framework. So anybody running that, I know that there's a few. There's one on this call, and there's a few others that we both know. But anybody that's interested in doing that, it doesn't have to be a company necessarily. And the creation of the synthetic data is something that we're internally doing tests on our data now, but would love collaboration there. And then anybody that would actually want to be one of the partners, so a data custodian that has some data now, and would want to, put in a little bit of time to become one of these, first proof of concept partners. I think it will definitely speed everybody has different, roadmaps and development cycles. So if we get a couple more partners that come into this, it just speeds us getting to at least two of us getting to the point where the proof of concept is, full circle. So those are the main ones I can think of. To reach me, quite easy, hopefully. So it's MG. My name is Michael Geer. So mg@humanity.email. Reach out. You can also find me on, a lot of different Telegram groups and stuff. But yeah, reach out wherever you can find me. So
thank you. That's an excellent plug. We're hoping to get some of the folks from groups like FedML.ai and Flock and a couple other folks to join as well. So this is all keeping in a good topic space for us. All right. Well, I think that's all for now, David. Unless we miss anything else, thank you so much for presenting today, and we'll look forward to the next session in a couple weeks.
Cool. Thanks, Wes. Thanks, Alexander. Thanks, everyone.
Thank you. Take care.
Thanks.
Yeah.